All right, here we got our homework. Given a vector in polar form, find the vector's component form. I'm going to go long form here on this first one, and then we'll go to the short version. So number one, this is going to be in quadrant one because 10 degrees falls in quadrant one. I would make this vector look something like this with a magnitude of 2. If we make a reference triangle for this, and we wanted to figure out what x was, we would do cosine of 10 degrees is x over r, which makes x 2 cosine of 10. If you put that into your, sorry about that, put that into your calculator, two cosine of 10 degrees, that's about 1 point, let's go to the 1 decimal point. That's about 2. No, we don't want to do that because the hypotenuse is 2. Let's say it's about 1.97. Let's do that. And then if we want to figure out what y is, we would do sine of 10 degrees is y over r. Multiply both sides by 2. And we would get y is about 0.35. So in vector form, in vector component form, I should say, this is to the right 1.97 and up 0.35. The short version of this is if you want to know the component form of a vector, it's the radius times cosine of the angle followed by the radius times sine of the angle. So we're going to do the short version for the rest of these. So for B, in component form, this is going to be 5 times cosine of 115 degrees, followed by sine, 5 times sine of 115 degrees. That would be negative 2.11 for x, and for y it would be about 1.29. And let's make sure that we have these are the correct signs. 115 degrees is in quadrant 2, that's left and that's up. So yeah, that makes sense. Number 3, in component form, it would be the radius times cosine of 222 degrees, followed by the radius times sine of 222 degrees. Using our calculator, 10 times cosine of 222 degrees, that's negative 7.43. 10 times sine of 222 degrees, well, that is negative 6.69. Does that make sense? It sure does. Quadrant 3, we are going left and down, so those would both be negative. Number 4, the components is going to be the radius times cosine of the angle, followed by the radius times sine of the angle. Sine of 333, that's negative 9.08. 20 cosine of 333 is 17.82. This is in quadrant 4. We're going right and down. Our signs are correct. I always like to check those because sometimes calculators can do weird things with trig functions. Halfway there. Perhaps we're living on a prayer. So we got 7 cosine of 11 degrees followed by 7 sine of 11 degrees. Seven cosine of 11 is 6.87. 7 sine of 11, that refuses for me to write sine for some reason. Good golly. So 1.34. Sorry for the language. I don't usually just utter out gollies like that, but you know, you start to get frustrated and explicits start to fly. Number 6, the components. It's going to be the radius times cosine of the angle followed by the radius times sine of the angle. Yes, I'm saying radius because the magnitude of the vector is the same as the radius of the reference triangle. 12 times cosine of 175 is about 11.95 negative style. 12 sine of 175 is about 1.05. Number 7, more of the same. We're going to have the radius times cosine of the angle followed by the radius times sine of the angle. Since the radius is 1, it's not all that important to write it. Cosine of 200 is negative 0.94. Sine of 200 is negative 0.34. 334 hundredths. All right, last one. Components are going to be the radius times cosine of our angle followed by the radius times sine of our angle. 4 times cosine of 340, 3.76. 4 sine of 340 is negative 1.37. All righty. That's how we do it.